Hello everyone. So again, last lecture we have seen about the construction and working details of the three-phase alternator. Now for this lecture, we will see detailing about the construction of the stator as well as the rotor of the alternator, three-phase alternator. So as we know that basically the main components of alternator has a rotor and stator. The stator has its stationary part of the rotor. Stator is stationary part and the rotor is a rotating part which is always fixed inside the stator winding. Now we will see the first upon the stator construction. It is a stationary part of the machine and it is built up for sheet steel laminations having slot on inner periphery. That means what? Simply, as we seen in the previous lectures, this the stator is basically used to provide. It is used to house the stator winding that we call armature winding. So for housing the armature winding, we are providing the different armature slots. So as shown in this particular figure, we have I have defined the different stator slot we call armature slot in which the different armature winding is to be housed. Okay, so all this stator core, it is made up of actually sheet steel material which is having a laminations. To reduce the eddy current and hysteresis losses, we should provide the laminations to the stator sides as well as stator different parts, and a three-phase winding is placed in these slots and serves as the armature winding of the alternator. That means for this, already we have seen in the last lectures about the advantage of the stationary armature compared to the stationary field winding. Okay, so here actually what will happen? So we are housing the armature conductors we call the stator winding into the different stator slot. These are the different stator slots or simple called armature slots. So here we are housing the stator winding we call armature winding. The armature winding is always connected in star and neutral is connected to the ground. So let me clear the one thing that for generation purpose, whenever we are going to connect this generator to any system or any hydro or simply generating stations, so for that particularly generator we are designing, so this generator is always having a star connected winding. Okay, because as we require the three phase supply, so it is necessary to provide the 11 kV generation. So for that, getting that, we should always connect the stator winding or simple called armature winding. It is always in star connections, and the neutral point always it is connected to the ground because it has again different advantages compared to the delta connections. And as shown in the next figure, this second figure, so this is nothing but I have shown this silent pole stator as well as sorry silent pole rotors with this armature winding. So as I stated in the last lecture, so we are giving the DC input for this particularly field circuit or we call it field winding here. Now this field winding which is connected to the rotor side, which is a silent pole rotor, and outer that we are providing the armature winding, and whatever once your generator start rotating, it produces electricity, and this produced electricity we have collected through the armature circuit because already as we know the Faraday's second law of Faraday's law of generation electricity electromagnetic induction. So according to that, whenever the conductor collects the flux, EMF is induced in that conductor, and hence armature winding produces the EMF, and which will be taken out through the different systems. So this is the part of stator. So we will move towards the rotor construction. The rotor carries a field winding which is supplied with a direct current through two slip rings by a separate DC source. Okay, the rotor, as we know, the stator, this is part of the stator, outer part is stator, while inner part is of rotor. Okay, so already we have seen about the advantage of the stationary armature. So we are considering here the armature is now the stationary part. That means we are mounting armature, which is called stator winding. It is in the stator slide. So the rotor carries a field winding which is supplied with a direct current. That means here the rotor having a field winding, and this field winding we are energized by using the DC supply. Okay, through the slip ring, simply called the brush and armature arrangement, or slips, simply called as a commutator and brush arrangement. This DC source we called exciter is generally a small DC shunt or compound generator mounted on the shaft of alternator. Rotor construction is of two types, namely as salient or simple called a projecting pole type, or simply second one it's a non-salient we call a cylindrical type rotor. So as we know that we are providing the DC supply to the rotor winding of the alternator. So this rotor winding, this DC supply may be get available through the separate generator we call exciter or simply called through the different battery systems. So normally nowadays, instead of using a DC generator, they are using the battery sources in the different generating stations. So we will focusing on the rotor construction. So as the first part, it's a salient or projecting pole type. Okay. So this there are two type of rotor. Already we have seen this type of rotor in the three-phase induction motor. So this silent pole rotor having we are considering here four pole silent pole rotors. So rotor has a different laminations, and over that we are mounting a field winding. So here these two are the brushes. Here these are the brushes, or simple called as slip rings, through which we are providing the DC supply. Okay, and through the brushes, this field winding we are mounting on each pole of the silent pole rotor. So this is N pole, S pole, N pole, S pole, and these are nothing but the field poles. In this type, a silent or projecting poles are mounted on the larger circular steel frame which is fixed to the shaft of the alternator. Of that means what? This projecting poles are simply called as silent poles, which is mounted on the large circular sheet steel. Okay, and which is already fixed on the shaft of the generator, and over that we are providing the different field winding. The individual field pole windings are connected in a series in such a way that when the field winding is energized by the DC exciter, adjacent poles have opposite polarities. That means this field winding are connected in a series. You can see this particular this field winding are connected in series. This field winding is connected such a way that this opponent, that means adjacent pole, should have the opposite polarity. That means this one, okay, this N and S pole, these two having the opposite polarities. Here again these two NS, NS, these poles having the opposite polarity. So in such a fashion, we are going to connect the field winding of the generator. So typically, low and medium speed alternator, which has speed of 120 to 400 rpm, such as those driven by diesel engines or water turbines, have silent pole type rotors. That means this silent pole rotor basically we are used for low and medium speed alternators. Okay, so we will move towards the non-silent pole. We call a cylindrical pole type. Now, as we shown that this figure is having this silent pole rotor, while this is nothing but a cylindrical. Okay, the cylindrical shapes of rotor. In this type, the rotor is made up of smooth, solid forged steel radial cylinder having a number of slots along the outer periphery. That means similar to that of your stator. Already we have seen about the stator has a different slots. Similar to that of stator, we are providing the these slots in rotor periphery also. The field winding are embedded in these slots and are connected in series to the slip rings through which they can energize by DC exciter. That means as we seen in the particularly the silent pole rotors. Now this is nothing but a silent pole rotor on which we are mounting the field winding. Okay, it is in connected in series. And series मध्ये कसं जोडलेलं आहे तर this adjacent pole should be of opposite polarity. म्हणजे इथं जर N पोल असेल तर इथं S पोल क्रिएट व्हायला पाहिजे. इथं N असेल तर इथं म्हणजे एक्झॅक्टली जे ऍडजस्टंट पोल आहे म्हणजे जे नेबरिंग पोल्स आहेत इट शुड हॅव्हिंग द अपोजिट पोलॅरिटीज. म्हणजे हे दोन्ही जे आहेत अपोजिट पोलॅरिटीचे पाहिजेत. ओके, हे अवेलेबल करण्यासाठी आपण काय केलं, आपण ह्या फील्ड वाइंडिंगला सिरीज मध्ये कनेक्शन केलेलं आहे लाईकवाईज. ओके, सो सिमिलर टू दॅट ऑफ युअर सेटर साइड वी आर ऑल्सो connecting a field winding in the different rotor slots. Okay, yes, here stator slot has like this structure. Similar, we are here in the stator slot we are having the winding of the stator winding. Similar to that, we are going to connect the rotor winding, we call field winding, in the different rotors slots. Okay, म्हणजे इथं जे आहे हे सगळे इथं काय काय these are the nothing but a rotor slot in which we are housing the field winding. Okay, म्हणजे rotor मध्ये either you can use this one silent pole rotor or you may use the cylindrical type rotor. And in the cylindrical type rotor there are different slots are there, we call rotor slots are there, in which we are mounting the field winding. Okay, and this field winding is energized by the DC supply which is available through the separate generator, DC generator, or sometimes maybe use the separate batteries. Okay, and this DC supply is obtained from generator generator or batteries through the commutator and brush arrangement. The regions forming the poles are usually left unslotted as shown in figure. It is clear that the poles formed are non-silent, that is they are not project out from the rotor surface. That means simply there is no any projector आहे म्हणजे इथं काय झालं हे फक्त एवढाच पार्ट प्रोजेक्टिंग ओके म्हणजे हाच पार्ट प्रोजेक्टिंग दिस इज नॉट प्रोजेक्टिंग दिस इज नॉन प्रोजेक्टिंग दिस इज प्रोजेक्टिंग म्हणजे फक्त प्रोजेक्टिंग म्हणजे काय हायलाइट केलेलं ओके these are the projecting these are the projecting simple called as silent pole rotors. Here there is no any projecting type structure, so simply this particularly non-silent type or simply called a or simply called as cylindrical pole type rotor has used specially for high speed alternators. That means the generator or alternator which runs about 1500 rpm or 3000 rpm speed and actually are driven by the steam turbines and use non-silent type rotors. Basically, whenever we require the high speed alternators, we should prefer the non-silent or cylindrical type rotor. And whenever the application of this particular speed is very low or medium speed, then we should go for the silent pole rotor. That means if we are having the input speed of 120 to 400 rpm, then we should select the silent or projecting type rotor. Or if we have the high speed input, that means if the generator having the speed of 1500 rpm or 3000 rpm, then we should prefer for the non-silent or cylindrical type rotor. Okay, so in the next part we will see about the some stator and rotor construction through the videos. So as we know that the alternator is an electrical generator that converts the mechanical energy to electric energy in the form of alternating current. Electricity is produced in alternator by electromagnetic induction. So as we know that there are two types of generators. First we call the non-silent pole type rotor as well as cylindrical type rotors. So we will see about the two types of generators which is constructed according to the position of the armatures. So in the first, as we've seen, it's a rotating magnetic field with a stationary armature, while a second one, a rotating armature with a stationary magnetic field. That means in the first part, we will see about rotating magnetic field. This is nothing but a rotor side. This is nothing but stator side. Okay, so this is rotor. This is one stator. So in the rotating magnetic field, we are considering the here field is rotating while armature is stationary. While here we are assuming that the armature is rotating while field is stationary. So in both cases, we have shown this is field winding, this is field, and this is both outer side we call armature winding. So we can see this. So here the field is now rotating while armature is stationary, while here the field is stationary and armature is rotating. So you can see these videos regarding that particular systems in both ways. That means in type 1 rotating magnetic field, while in the type 2 it's the rotating armature sides. Now we will see about the construction details of the alternator. We call the main parts of alternator. So these are the so as we know that this is nothing but a rotor, a stator, outer converter, regulators, as well as bearings and different parts. So in this part we will see about the main parts of alternator. So as this is a rotor slides in which we have wounding the rotor winding. This is called a field winding. Now these are the bearings. These are the outer cover we called simply main frame or yoke. Now this is regulator. Simply it is regulator is used for the providing the DC supplies. It may be not available for it any modern alternators. Now these are the commutator and brush arrangement. These are the pole core. These are the stator winding. Now actually what will happen you can see. Now this part is a rotor which is we are fixed into the part of stator. म्हणजे हा तुमचा रोटरचा जो पार्ट आहे हा रोटरचा पार्ट आम्ही काय करूया या स्टेटर मध्ये पूर्ण असा हाऊसिंग केला आणि हा पूर्ण बाहेरची बॉडी these are nothing but a pulleys. These are the basic bearings for reducing the friction losses in between the different rotating parts. Now we will see first on the principle of working of the simply rotor side, that is a rotor construction. So again, as we seen in the previous lectures about rotor has a two types. It's called stationary armature. It's of silent pole rotors or cylindrical type rotor. So here you can see this. We call considering the silent pole rotors. So these actually what happens. So these are nothing but a winding. Okay, these are the nothing but rotor slots which is used to provide the different field winding or simply rotor winding. These are the bearings, this is the pulleys, and these are the different rotor slots in which we are housing the field winding. Okay, and once it is start rotating, obviously the field winding is produces simply called a field. Because of this field, the N and S poles are created. बिकॉज आपण इथं काय केलेलं आहे, इथं या पूर्ण रोटर वाइंडिंगला आम्ही काय केलं, डीसी सप्लाय दिलेला आहे. म्हणजे डीसी सप्लाय विच हॅज टू पोलॅरिटी प्लस आणि पॉझिटिव्ह निगेटिव्ह पोलॅरिटी असल्यामुळे इथं काय करले, फील्ड वाइंडिंगमुळे इथं काय करतोय, हा इथं मॅग्नेटिक फील्ड क्रिएट करतो. म्हणजे फील्ड म्हणजे इथं जेव्हा ह्या पूर्ण रोटर करंट इथं फ्लो होणार आहे, इट विल क्रिएट अ field and which has polarities of N pole as well as S pole, that is North pole and South pole. Now we will see about the detailing about the structure of this particular system. Now these are this we call the silent pole rotors, and in the silent pole rotors, these are nothing but the silent pole rotors in which we have providing the different armature, sorry, different field winding. So there are number of turns we are mounting in the rotor side, we call field winding. Now it is excited or it is energized by the DC source. We call it the polarity of plus and minus. Now just assume that it is connected in the system. That means it is connected in the generator. Now once the current will flow through this side, we call the rotor winding. Obviously because of this DC sources or DC energy sources, the field winding, there is flux is produced in the rotor side. म्हणजे एकदा जर यातनं पूर्ण या वाइंडिंग मध्ये जर डीसी करंट फ्लो व्हायला लागला प्लस मायनस मधून, तर काय होणार, इथं फ्लक्स प्रोड्यूस होणार. बिकॉज आपल्याला माहिती आहे की एकदा कंडक्टर मध्ये करंट फ्लो तर फ्लक्स याच्यामध्ये प्रोड्यूस होतो. ओके, सो बिकॉज ऑफ दिस इथं काय होणार, फ्लक्स प्रोड्यूस होणार. Now this will create the fluxes, and now after that this fluxes is going to interact with the stator slides. Now we assume that these are nothing but the stator conductors. Okay, म्हणजे हा तुमचा पूर्ण रोटरचा पार्ट आहे. सपोज assume that these are the stator windings. हा पूर्ण stator winding बाहेरचा आपण assume करा. Now what will happen once these fluxes are going to interlink with the stator conductors? Now you can see this in the video. These particular rotor fluxes are going to interlink with the stator winding. Now because of this, now due to this, what will happen? The EMF is induced. We call the sinusoidal waveform, or we call AC waveform, or AC sinusoidal wave is produced in the stator slides. Okay, म्हणजे stator winding मध्ये या पूर्ण आता EMF किंवा alternating EMF इथं तयार होणार आहे. ओके, म्हणजे इथं एकदा इंटरलिंक झाला हा फ्लक्स, स्टेटरचा रोटरचा फ्लक्स इंटरलिंक स्टेटर कंडक्टरला झालं तर काय होणार, इथं या पूर्ण स्टेटर वाइंडिंगला आता EMF तयार होणार आहे. Now this the alternating wave has the frequency of this particular system, that means frequency of the generated EMF is basically depends on the number of poles as well as the speed of generator. That means P is nothing but a number of poles and N is nothing but it's a speed of this is in RPM. Okay, so this frequency depend as we know that F is equals to P into N divided by 120, and by using this formula we can calculate the frequency of generated EMF. Now just assume that there are, for simplicity we have in the first figure, for simplicity we have shown only one windings are there, only one wave. That means for this one, as we know that there are for three phase alternator there are three different windings, R phase, Y phase, B phase. For this simplicity working we have already assumed that there is only one winding. म्हणजे फक्त आपण इथं एकच वाइंडिंग अज्युम केले हे स्टेटर साइडला. ओके, तीन वाइंडिंग स्टेटरला असणार आहेत ना आर बाय बी चे. आपण फॉर सिम्प्लिसिटी काय केलं, इथं फक्त एकच वाइंडिंग कन्सिडर केले, आणि जेव्हा इथं हा फ्लक्स रोटरचा फ्लक्स जेव्हा स्टेटरच्या एका वाइंडिंगला इंटरलिंक होणार आहे, इथं ऑलरेडी सायनुसॉइडल किंवा साइन वेव्ह किंवा EMF तयार होणार आहे. ना आता या केसमध्ये अज्युम करा की आता तीन वाइंडिंग प्रोव्हाइड केले किंवा तीन वाइंडिंग फिक्स केले, दॅट मीन्स R, Y and B. Now what will happen? And now this R, Y and B, that means R phase, Y phase and B phase, this three phase winding, we are going to connect in the star connection, and the neutral is nothing but a star. म्हणजे न्यूट्रल पॉइंट म्हणजे स्टार कनेक्टेड वाइंडिंग आहे. ओके, स्टार कनेक्ट वाइंडिंगला माहिती आहे तुम्हाला की दिस लाईन व्होल्टेज अँड फेज व्होल्टेज ह्याच्या रिलेशन ऑफ √3. ओके, दॅट मीन्स इन दिस केसेस what will happen, line voltage BL equals to phase voltage BL equals to line voltage divided by √3. Now we can assume that this is nothing but a star connected winding in provided for the three phase connections. Now what will happen, once it is start rotating, now because of this, the field winding which is of DC supply, which is generated, which is we call energized by the DC sources. Now it is going to interlink with these three windings. म्हणजे इथं काय होणार आहे, जो मगाशी आपण एक वाइंडिंग कन्सिडर केलं होतं, आता थ्री फेज वाइंडिंग आम्ही प्रोव्हाइड केलं. ओके, मग काय करणार आहे, इथं जेव्हा मी डीसी सप्लाय, जेव्हा ह्या रोटरला मी डीसी करंट देणार, तर इथं फ्लक्स क्रिएट होईल आणि हा जो फ्लक्स होणार आहे तो आता तीन डिफरंट वाइंडिंग बरोबर इंटरलिंक होणार आहे. मग आपण एक वाइंडिंग ठेवलं तर मग अशी एक वेव्ह जनरेट होत होती. ओके, but because of the three different winding which is placed in the in particularly this stator slides or stator side, now what will happen, these fluxes are going to interact with these three different windings, and because of this what will happen, the three phase AC waveform will generate. We call, I shown by the with the help of the current color code. This is nothing but R phase, this is for Y phase, and this is for B phase. And now these three having phase shifter, or simple called 120-degree phase displacement. You can see these videos. Now this is a clear image of this. Now this part is a rotor. Now this is called a silent pole rotor. Now it is rotating, and while this rotation, this we can assume, this you can see this is nothing but this rotor is rotating amongst in the stator winding, and it will produces the own fluxes, and these fluxes are going to link with the different stator windings. म्हणजे इथं आर फेजला कनेक्ट इंटरलिंक व्हायला, इथं वाय फेजला, इथं बी फेजला इंटरलिंक व्हायला लागले. And because of this, here the three phase windings are generated, or three phase AC supplies are generated. Now you can see this, these are the three different phase, AC waveforms are generating. That is we call the three phase AC supply, AC voltage is generating, which is of frequency, which is determined by using this relation F equals to Pn divided by 1.2. Simply we call, here we are assuming that the speed of 1800, that is 1800 rpm. Now you can see this, the actual principle of working of the generator. That means इथं आम्ही काय केलं, इथं आम्ही अज्युम केले की हा जो पार्ट आहे हा पूर्ण रोटरचा पार्ट आहे, ह्याच्यावरती आम्ही स्टेटर वाइंडिंग प्लेस केलेला आहे, आणि एकदा का हा फ्लक्स इंटरलिंक होईल त्या केसमध्ये आता इथं जनरेटरमध्ये इलेक्ट्रिसिटी, किंवा सॉरी इथं स्टेटर वाइंडिंग किंवा सिंपल कोड आर्मेचरमध्ये इलेक्ट्रिसिटी प्रोड्यूस होणार आहे. So you can just, and these are, so I am showing this particular color, these are nothing but a direction of the current. Okay, just you can assume that this, just sometimes it flows like inward and outward, because as we know that the AC waveform starts from the zero, again it reaches to the maximum positive max, again it reaches to the zero. That means एकदा इथून झिरो मधून फ्लो झाला, इथं मॅक्सिमम पॉझिटिव्ह मॅक्स काढतोय, परत निगेटिव्ह झिरो, अगेन निगेटिव्ह पीक, अगेन द झिरो. दॅट मीन्स बिकॉज ऑफ दिस ओनली the direction of current is going to change in this particular system. So again we will focusing on the rotor slides. So this rotor we call simply pole cores having the lamination structure. As we seen in the DC motion or a DC generator, all the pole core having the different laminations. Okay, that means laminated, all this म्हणजे एक संद दिसत असलं तरी पण हे सगळं laminations आहेत. The laminations are providing to reduces the eddy current as well as the hysteresis losses. And these laminations are having the metal sheet, or simple called sheet steel laminations. Now, on which we are providing the field winding over it. And this field winding, as we know that it is excited by the DC sources. Now, just assume that. Now, here purna laminations are purna ha purna. It is all pole cores are laminated as shown in particular these pictures. Now, on which on this pole we are mounting the on this pole we are mounting the field winding. आणि field winding हे सगळं मगाशी बघितल्याप्रमाणे सगळं सिरीज मध्ये, म्हणजे इथून सपोज these are the two slip rings. Okay, for simplicity I showed these are the two slip rings. हे स्लिप रिंग दोन आहेत, आणि ह्या स्लिप रिंग मधून काय केलं, इथं हे कनेक्टेड आहे, इट इज इन कनेक्ट, ऑल दिस फील्ड वाइंडिंग्स आर कनेक्टेड इन सिरीज. नाउ दिस फील्ड वाइंडिंग वी आर energized, or we are going to energize through the DC sources, or simple called a DC source. So these are the pole cores as we seen in the this structure. So as here, now these are the part of the DC source. That means we are going to connect the DC source here for this two slip rings. I call first for its polarity. First is for positive polarity, second one for its negative, because as we know that DC has a two polarities plus and minus. So मी काय करेल DC चा प्लस सोर्स इथे कनेक्ट करा, निगेटिव्ह सोर्स किंवा निगेटिव्ह पोलॅरिटी इथे कनेक्ट करा. सो काय होईल, हे सगळं सिरीज मध्ये कनेक्शन आहे आणि मग ह्या अशा कनेक्शन्स मग काय होणार, या फील्ड वाइंडिंग मध्ये obviously the flux is produces. And as we seen in the some previous videos, the EMF is generated in the stator winding, and this EMF generated EMF we are taking outside through the different systems. Okay, so that's it from the construction of working of generator. Okay, construction as and working principle of alternators.